Jeff Pierce, which in addition to recently combining the powers of Go, Redis, and Cassandra for monitoring, I urge you to check his GitHub page. He is also a technomancer. Do you know what technomancy is? Technomancer. So I looked this one up in Wikipedia. So it's technomancy. Any sufficiently advanced technology is indistinguishable from magic powers. Specific uses of technomancy powers include causing devices to malfunction and traveling to a cyber world. So I've traveled from the Bay Area, San Francisco, to Tel Aviv. Please welcome Jeff Pierce.
I mean, it would be a good DevOps engineer after all if I wasn't breaking things on a constant basis. So hi, I'm Jeff Pierce. I'm from change.org, and let me figure out my mouse here. All right, and my talk today is going to be on how I got a real-time metrics and distributed monitoring system in place, and what some of the pitfalls that we hit in our specific use case, and also how to drive adoption of it among the different development teams. So, a little bit about me. I am a senior DevOps engineer at change.org. That's my email address, my GitHub, and my Twitter handle. Please feel free to reach out. I also especially appreciate feedback on the talk. A little more about me. That is an official company headshot, by the way. I consulted for Citigroup on their high-frequency trading servers. I had stints at Apple and Rackspace, and I am the project lead on Cassandra, which is the tool that was described during my introduction. So, a little bit of background on our situation. At change.org, we are a global platform where people can start and win campaigns for change. We want to give people the opportunity to make the change and become the change that they want to see in the world. We have 120 million users worldwide. It ticked over just about after that screenshot got taken. And we have a rapidly expanding user base and engineering team. We're hitting the point and scale where we want to go from 100 million people to 1 billion. We want to ramp up big and fast. Part of our traffic patterns and why we've had a lot of trouble with monitoring and metric solutions in the past is it's very unpredictable. If a movement or a petition takes off, it hits the news, something like that, we go up in a heartbeat. An example is in Italy, we had a petition recently about things being made in Italy that might not actually have been made in Italy. And on a talk show, someone mentioned this petition, and we went from a slow day to 4 or 5 times normal traffic immediately. Like no ramp up, it's the link got posted, and then everyone's going to the site to sign this petition. So, we went to build something ourselves. The first thing we asked ourselves is, well, do we really have to build it? I mean, if you can use someone else's tools or something like that, hey, let's do it. It's less work that we have to do. But, you know, we just weren't able to find a solution in the limited amount of time that we had to come up with something that was going to meet our needs. But we definitely tried. One of the things was we weren't happy with the pricing on some, especially for auto-scaled hosts. You know, we weren't happy with the resolution of the stats we were capturing. Instead, you know, we were getting things at 30 seconds or a minute or 5 minutes. And when we have the extreme spikes that are short term, that was flattening out a lot of patterns that we wanted to see. So why do we need the monitoring distributed and these really high resolution metrics? Like, for example, most of the metrics that we're capturing in production are coming in every 6 seconds, and we have the ability to give them every second while we're stress testing or for certain things where we want to be able to see things real time for troubleshooting purposes. But the reason why we need these is we really wanted these servers to monitor and provide metrics on themselves. We want as few things as possible that were externally or centrally monitored. Because in a cloud world, a centralized service is asking for failure. If you're in AWS, all of a sudden, oops, that instance went away. It can happen. We really, you know, as I said, for us, the high resolution metrics are just awesome. It gives us much deeper troubleshooting ability. It lets us see patterns that weren't visible at the lower resolutions, as I mentioned. And it also lets us give a really slick presentation like any product, even aimed internally. When you're able to show off a great feature, it really helps pick up internal adoption, buy-in from management, things of that nature. It also gave us faster response times to outages. One of the monitoring platforms that we were using, that we had done externally prior to building our own, there were cases where when we were testing this and had it on only a few of our products, there was an issue with it. And we knew about it within 24 seconds of it happening. It took 4 ticks of our monitor system to figure out something was up. We were already addressing it and almost had it fixed by the time our previous monitor, which was still in place on a 5-minute scale, even let us know that something was wrong and hit the pager. And then finally, we want to be able to auto-scale on our own terms. We want to use the statistics and metrics that we care about, not just default ones like CPU or network traffic, something like that. We want to be able to drive that with the metrics that, we care about. If you were going over our traffic patterns, sometimes that's going to be how many signatures are we getting, because that's a separate service from just the front end. Just things of that nature. We want to be able to really have fine-grained scaling. So what else influenced our decision for going with our own setup? Well, we were pretty understaffed. We were getting a lot of engineers in the door. And in the San Francisco market, people who can do both systems and code are in very high demand, and it was tough to get them in the door. We would interview 6, 7 people and give them offers, and someone showered them with money, or they wanted a higher profile position. It was tough to get people in the door, so it was something that, with that rapid growth, we needed something that had a low implementation time. More specifically, it needed to be something that we were going to be able to put in immediately. And we needed to rely on the knowledge that the team already had. Especially, not only does that reduce the time from coming up with the idea and implementing it, but again, if you're using tools that your team is already familiar with, it's going to drive adoption, even if there's possibly a better tool out there, but no one on your team knows it. You definitely want to build your tools around the talent that is already on your team, what they've used, what they know, and try to make that fit before going for something that might be a little bit better fit, but no one knows about and will need to be trained on. So, and then finally, we needed something that had relatively low maintenance and relatively easy scalability. And with that, we started to search for a solution. Sorry about that, I have a little bit of dry mouth, one sec. So our first attempt was, let's make absolutely sure that we have to build this on our own. And we started doing trials with some other providers of external metrics. And in our case, we were really unable to find a provider that met both the price or resolution requirements. We didn't get a chance to check out a whole lot of companies at the time we were building this. But the big issue that we had was that none of them really had reasonable pricing for the temporary auto-scaled pooled host. A lot of things that we saw was if a server was in their system, even if it had only been up for a couple of hours, we were still getting charged for that for an entire month or even the term of the contract. And with all that in mind, we said, well, let's see what we can come up with in-house. Let's see if we can beat that. So we did, at change.org, we call those spikes, where we spend a week or two figuring out, hey, is this something we can do viably? And if so, then we go for the minimum viable product on it. And part of this means was we needed to define our requirements for what that satisfactory solution would be, rather than just, well, we're not quite getting what we want from someone externally. So the requirements that we came up with for the do-it-yourself stack, that's what DIY stands for, is we need to leverage tools, like I said, that the team members were already familiar with. In our case, that happened to be the good old Etsy stack of collecti, statsd, and graphite. Thanks for that, Etsy people. Also need to be, again, relatively low maintenance. We were very understaffed at the time. The less time that we're spending maintaining this is the more time that we're actually working on deployments or converting more of our legacy infrastructure to something that's a more modern DevOps setup. And then finally, we needed something that was flexible, resilient, and distributed. Flexible meaning that there are multiple ways that we can try to implement it to really figure out what's the best fit for us. Resilient because if your monitoring system goes down and there's no way to, you can't fail over somewhere or it's not distributed out, well, now no one's watching your systems and you don't know what's going on. When you don't know what's going on, you're already broken even if the site's running fine. And then it really needed to be cost competitive with the services we had tried externally and give us the higher resolution of stats we were looking for. And then, like I said earlier, we would find ones that had a really good price, but the resolution was 1 minute or 5 minutes, which wasn't good for our needs. There were providers that we could get that higher resolution, but we couldn't use their built-in checks for it. We still have to write our own checks, which is the majority of the time in this project anyway. And then finally, we wanted something that used as many parts and services that we already had in our infrastructure as possible, which again, that brings down our tool training time. We make better use of our own limited time because, hey, we already have our config management cookbooks and stuff ready for that. So what we ended up settling on is collecti and running statsd as a collecti plugin. As anyone here who's used it know, it has a wealth of pre-made plugins for monitoring different services, your system, et cetera. Saves time for us. We're running it on every server, so every server is monitoring itself and then reporting out. And then for the checks that collecti doesn't do, we're basically using it as a super cron to run our own custom checks, so that way they run every 6 seconds, or in some cases, every second. We also use Cyanite. This acts as our cardboard receiver. It's also where we are querying for the statistics. This uses Cassandra as its storage backend, uses Elasticsearch to index the stat paths. And we're already using both of those. Cassandra, we store a lot of our data in that does not have to be immediately correct or doesn't deal with finance or something like that. Elasticsearch is what we back our actual search on the page with. So we already had knowledge on how to implement those services and run them well. Cyanite also clustered very easily, and it seemed pretty fast, especially in the earlier releases of it. And then we also, instead of implementing full graphite, we went with the stripped down graphite-api. It is stripped down, it runs a lot faster. What it doesn't give you is the dashboards or the composer or the nice pretty stats tree. So obviously we're going to need something that provides that. We ended up going with Grafana. It is fast, very responsive. It has a really great feature set. Full mouse over on stats, you're able to just click on one area, drag it over a little bit, and it will automatically zoom into that time frame. Integrates with a lot of different time series databases, so even if we decide that what we've got now doesn't work, we can still use Grafana as a front end. But the big one, the biggest deal on it is that the dashboards for it are JSON. It's templable JSON. And as we're a web company that has a lot of developers who are very familiar with using JSON as a data structure, that's a big deal. Because we want the developers to own the dashboards. We don't want to have to do that in infrastructure and operations because frankly, the devs know better what matters, which stats are important, what should be graphed, so that way we're not just collecting everything and then flooding ourselves with information that isn't useful. So the developers can set up their own monitors and manage that dashboard, and it's a lot better than us trying to figure out and flooding ourselves with stats. It takes work off the plate of the DevOps team. We were understaffed, and if developers can handle this, it also, it takes more work off us, puts it on them, gives them increased ownership, and we can check in this dashboard with the app code itself instead of having to manage it through, our deploy repository or our DevOps repository. That is, that's really great because now it's a visual reminder, hey, if the developer is updating something about this service or this application, they need to update their dashboard too, and it's there with the rest of their code. Not only that, for dashboards that are pretty common amongst different services, like, hey, if we're going to be using Nginx as a front end for a service, well then we have we can template out the checks that we care about in Nginx and apply them to that service, give it its own dashboard, and we can just put that in change config as a custom library or just, a template file. It works out really well. And then finally, as I touched on at the beginning of this section, the JSON is a familiar format to our devs. And again, when we're shooting for, increased adoption rate, because if you build a great tool and nobody uses it, it's useless. You've wasted time on it. So the fact that we can go, hey, let's use something that we already know, that our devs already know, are familiar with, and they picked up on it right away. Then here's a little architecture graph of what it all sort of looks like at a high level. We have our app servers, our central monitor for the stuff that we do have to monitor centrally, our stuff that gets our external stats like our web page speed around the world, sends that over to Cyanite, indexes the stats in Elasticsearch, puts the actual stats themselves in Cassandra, and then Grafana and graphite-api query Cyanite whenever you have a dashboard request coming from anywhere. And also, I forgot to mention this other reason why we did go with Grafana is that, hey, we're a Google shop as far as we use Google Docs. We have our logins done SSO with Google, so there is a Google Auth plugin for Grafana, so that's even better there. We don't have to manage that login. It's not another thing. If someone leaves the company, then we disable their Google account and they can't log in anymore. We don't have to worry about it. So that's the metrics. Let's talk about the monitoring side of it real quick. First thing we did was we're writing and running some simple scripts to query Cyanite to get a lot of our aggregated metrics, and for a lot of the actual stuff we want to alert on. And these accompany the systems checks from collecti that we really care about. We use PagerDuty for alerting and paging, mainly because I can't build a better tool than that right now. They've implemented that great. I'm a big fan. And then again, we only want to use external monitoring to check application-wide or aggregate stats, and also for things like site up-down. Obviously, it works best if that's not in where your data center or your AWS region. You want to make sure you're actually available to the outside world, no matter what your stats internally say. And then we want to use those external services as little as possible, which again, for site and servers up and down, things that we can't implement better than an external vendor, because again, our time is precious and we're understaffed. We need to get that done. And then, or there's services that we can't beat for the price, like PagerDuty. And then finally, we want to template as many checks as possible for easy management by change control. Because again, if a developer doesn't have to do a whole bunch of work and implement it every single time, we're going to get quick adoption, they're going to get excited about it, and we are going to be able to roll this internal product out and really make it shine. So we need to see, how are we going to get developer buy-in in this situation? First thing is we need to make it simple to add stats and monitors so that we get this high adoption rate. In our case, this was make importable code in the languages that we're using. We started as a proof of concept that I just call monitorlib. It's an internal library for Python. So that's what I write most of our checks in, even though we're a Ruby shop. I learned on Python, and it's, again, if I've got to implement something, I want to use something that I know to get it out there fast. So this saves time. Developers don't have to evaluate a bunch of different implementations of a statsd client because we're going to provide it for them. It helps dry up our code, with dry being don't repeat yourself. We only want our statsd client and our PagerDuty client, things like that, to be implemented once per code base. Let them import it, makes it easy. If something does break, we're not trying to troubleshoot 4 or 5 different clients here. And then finally, that gives us a very, very standard and trainable implementation. we get it done, we show it off in demos, we sit down with the development leads, and we train it, and now it's the same across all of our departments. And then, like I just mentioned, demo the ease of use. Show how easy it is to use because we've done the legwork for you. We provided the tools, we've led the horse to water. Now all you have to do is show them how to drink, which, if you know developers, showing them how to drink is not a hard task. Well, at least for me. And then finally, the other thing you want to do is consult the individual influential developers on the importance of getting these stats everywhere. Because you don't just want to go out and tell people how great it is and show them how great it is. It's much more effective when you can get someone else to do this on your behalf because you've gotten them excited about this service. And this goes for an external product or an internal product. Get people to evangelize it, and those people are going to go out. They're your team leads. They're your principal architect. These are the people that are your thought leaders within your own company, and get them on board, solicit their advice, and then show them how they can go to their teams and get it in place, get it running, and have that support. It makes it a lot easier to implement new systems, whether it's this or anything else you choose. And finally, once we've done all this, we've gotten our developer buy-in, we've evaluated what we need to do, we've got an implementation in place, it's been running for a while, so what do we get from all this work? Well, we have faster code, by far. We were able to find situations that were getting flattened out in our metrics that had a lower resolution to them, where there would be spikes as far as response times went and other things of that nature, where services weren't communicating as fast as possible in certain situations. But the big one is for some of our services, we brought response times down by 25% or more on a lot of things, and that's a big deal. And here, this is one of our dashboards. It's a low traffic time period, but we're really able to see how many, we got up top the numbers for just quick looks at it. Then below we've got our graphs that are showing up where, we've got our median response times, we've got our 95th percentile. The reason why we have average there is historically that was a metric that people cared about, and while average isn't really all that great, again, you give people something they're familiar with and they're gonna be more willing to adopt the new thing you're putting in front of them if there's still something there that looks like the old thing. We've got faster and fewer rollbacks because one, with these, with our stats coming in faster than before, if something does manage to get through our testing and our staging process, things like that, we know much faster if we need to roll that code back. We're getting stats now in our staging environment that, if we were using an external vendor, was money that sometimes wasn't in the budget, that will, cheaply, since it's already implemented for prod, show the issues we weren't catching before there, which helped, again, fewer rollbacks there. But not only that is, when you're gathering metrics on everything, you can also put your business KPIs in place. And show you what I mean by that, here's our main deploy dashboard that decides when, if we're available to deploy and what happens after a deployment. And if you notice there, the big graph front and center that's top and the left is KPIs. That is all business. This is our signatures, and I'm passing it again. This was a slow time of the day when I took this because I was up late and doing a slide deck at the last minute. But these are, most of the stuff that we're looking at here is business. The only things that's really technical here are the Redis commands per second, because for us, with Redis goes way too high, it has fallen over for us. And then if we're getting a bunch of 500 class requests on production. But everything else there, it's business-based, and we're able to see that stuff a lot faster, to see that even if the code is good and we're not throwing errors, if it's dropped our signature rate because we've made a change to one of our pages and we didn't catch it in earlier testing for some reason, well, it's showing up front and center, we're getting it real time, and we can go, hey, we need to roll this back until we figure out what happened. Because if we're not getting signatures and we're not getting people to promote our petitions, we're not, one, doing our job as change.org to try to make change and get people to sign on to movements, but hey, we're not making the revenue that we need to keep our doors open and keep making change. So that is as important as the technical stuff that would cause a rollback, like, hey, my response times went up or something like that. Now, we've also finding our problem instances easier than before. I'm sure you all know that when you bring up instances in the cloud, a lot of times you don't have that box to yourself unless it's a really large instance. And you do have noisy neighbor syndrome, especially for some vendors out there that let you use unused resources on the host machine if no one else is using it. Well, sometimes that doesn't get capped as fast as they would like. So you'll have an issue where you got a noisy neighbor using a lot of resources, and now we've got an instance that's responding 40 or 50 milliseconds slower than every other one. And it makes it much easier to find this problem after we moved out code, because we can sit here and we can break up our servers per second and everything like that by the actual servers themselves and not just an aggregate. And we're able to capture all these stats and set up easy visualizations to see that, oh, hey, we just brought up a new host. It's taking fewer requests and its response time is much higher. We need to kill that host because that's going to cause issues that are going to be visible externally to someone who's using the site. We can also set up visualizations like this, where, hey, this tells me everything I really need to know about a system's overall health. How much traffic it's pushing out, the CPU usage. Load is there because while it's not particularly useful for troubleshooting, it's, again, people are used to seeing that, and familiarity will help adoption. So then the big thing that we got is we've also got faster and easier troubleshooting for even non-instance items. Because in our case, we throw a stat whenever you would normally be logging something. If it would be logged in debug mode, it needs to throw a stat. And one of the big wins we get by that is we hardly crawl logs anymore, especially on the production engineering team. I haven't looked at a log for troubleshooting for our main front end or our back end services in going on 4 or 5 months now, because anything that I would really care about that's going to be in that log is sending a stat. It also means that we don't have to do a whole lot of central log collection. It's another service that we've replaced by throwing a stat on everything. It also means that now our logs can be easier to be read by a machine. We can implement them in JSON because humans are rarely going to be reading them. And that allows us to parse them for business intelligence or other reasons a lot faster without having to have separate logs for that as compared to the actual systems themselves. We can also visually see which instances and servers are acting up, like I showed you. So one of the nice things is once you have a set of dashboards that you're viewing on a regular basis, is you start to notice patterns. Once you've seen how your site looks for a while, you can come in and you're coming in for the day, and you look at it and you go, something's wrong there. That pattern's not right. You might not know what it is. It might not be bringing your site down, but you can visually see that this is happening. You need to check out something and then start your troubleshooting steps before the problem ever comes to a head and brings you down, slows you down, costs the company money, stops them from achieving their mission, something like that. Another nice thing about using Grafana is you're able to create dashboards really quick and really fast just for scratch purposes to compare multiple sets of stats. I don't have to sit here and have 20 terminal windows open anymore, tracing connections all the way through my stack, because I can throw together a couple of graphs for, this is how my flow should be. My front end is going to talk to petition service to get a petition to show to someone, and it's going to talk to user service. So if the person decides to sign, it's there, and if they sign, it's going to go to signature service. So while those all have dashboards of their own, if I need to do troubleshooting along the path, I can whip up a scratch dashboard that has all this stuff there and zoom in on it to very high resolution and take a look at what's going on, see where this problem is coming out with. Again, I don't have to hunt through logs. I don't have to watch individual machines on a terminal. And you can also use it to get stuff that you would normally go on a machine to check anyways. Like in this case, this is just a dashboard that basically just implements the info command in Redis. This is going to give us our PID. For type there, it's going to let me know if it's Redis or if it's Redis Sentinel. It's got the amount of connections, our used memory, how long our background saves are taking, whether or not it's a master, things of that nature where it's really quick to just get it at a glance, where I don't have to go on a server to check it. I don't have to look at a bunch of graphs. I'm putting it all there in numerical format like I'd see it on the machine. But the biggest win of all was that it heavily increased the communication between our feature developers, our product developers, and the infrastructure team, who are now our DevOps team. And this is the goal of DevOps as a philosophy, is increased communication, breaking down those barriers. And it's a huge win, especially when we're a startup, we're trying to do this major scaling operation. We're growing very fast, so there's new faces in the office all the time. Communication is the biggest priority that we have in order to pull this off, in order to do this mission that we want to do. The app developers themselves, as I mentioned earlier, they have an increased sense of ownership because they're choosing what stats to capture and which dashboards matter. They feel like that they're getting to decide, this is what we care about. These are the stats that we care about as far as my application is concerned. Seems like a little thing, but it's one of those things where when I talk to my developer, that's the biggest feedback I get, is I feel like I own it. And then, honestly, when something is wrong, like when it's a business KPI instead of something very, very visible, like the site is slow or the site is down, it can be easier to accept it from a graph or stats than it can from the ops person. Because if you're very, very invested as a developer in getting this code released and someone tells you there's a problem, you don't always want to hear it, especially if you pulled a lot of late nights. But it decreases friction to have these statistics there and leaves the lines of communication open, so your infrastructure team or your DevOps team isn't the bad guy saying, you've got to roll this back, I know you've worked hard on it. There is an unforeseen circumstance here. We're able to point to the stats and not only go, this is why it has to roll back, but when you go back to test it, this is what you need to look at. Look at it right here. And that is, again, the biggest win from all of this is not so much that we've implemented a very nice statistic system or that we're doing our monitoring distributed, but it's that the tool itself not just does its job, but helps open communications lines and break down those departmental barriers because it's being designed to take advantage of people's skill sets on their teams and being able to, like I said, just communicate with them. Stats are used for communication. It's communicating whether something is down, communicating how much of something you're doing. And not only that, you can use it to actually work on your people communication as well. Getting that buy-in, getting people on board is, again, this is a core philosophy of DevOps. And with that, winners ask questions. So do y'all have any?
Yeah, so you mentioned choosing Cassandra and cyanite.
Mm-hmm.
And I was wondering what is the decision process that stood behind it? Mainly you're familiar with Cassandra, or you checked other monitoring databases like Influence, which is also this?
The question was, what was some of the decisions that went into choosing Cyanite and Cassandra? One, it was we already had Cassandra as a database in our system where we stored data. So one of the things we were trying to do to get implementation time down was use stuff we already use, even if it might not have been the absolute best tool for the job. In this case, I mentioned Cassabon earlier. That's actually a replacement for Cyanite that we're working on. I was actually hoping to release it to you all today, but it needs a couple weeks more work. But we will be transitioning to that. But that was a decision behind it. And it was also, these are tools that, as we've broken it out more, if we decided we didn't like one piece of it, we could replace one piece and not have to rip out the entire stack and redesign it.
What kind of latency do you get on the actual dashboards?
The question was, what kind of latency do we get on the dashboards? It really depends on what's being aggregated in there. One of the flaws of the setup that I showed is the original goal was to try to do it without an extra carbon aggregation layer. One of the reasons why we're moving to Cassabon was that didn't work, And I don't want to have all of the carbon aggregators in there if I can actually do that where my stats are being collected. So part of what Cassandra will do is actually route stats around to which instance should own them according to a Pearson hash. But the actual latency that we'd see for dashboards that were very numerical based, weren't doing a lot of aggregations, they'll pop up in under a second in a lot of cases. Some of the ones that are busier, like if we're under a whole lot of load, that web statistics one that we showed, it will occasionally time out. And that's one of the things we're trying to address going forward. Because again, this isn't about how we did something awesome, it was what was our process for getting a solution in place. So there's definitely flaws with it. And that's one of them, and that's a really good question to ask.
You mentioned before that now that you have these dashboards, you can start and seeing maybe the guy who looks at these dashboards continuously can start seeing patterns in your eyes. Did you notice a real value from that, and have you considered using some kind of automatic system that detects these patterns and accommodates that?
The question was how much value we're seeing from people being able to view the patterns like I talked about, and if we're considering some kind of automated solution. The answer is yes. That's actually going to be next up on our plate once we have some other work that's been prioritized over in our department done. You can get dashboard fatigue. Sorry, yes to both of those questions. Yes, the value is there because if you make it easy for someone to look at how their code's doing, again, they'll adopt it. If they can look on the big screens when they walk in the office, take a look at their app before they even sit down for the day, and it's sitting there right by the restroom, so if they walk by to go to the restroom, they look up at the stats on the way there. There's a huge value from that. But you can get dashboard fatigue, so one of the things we are definitely looking at is getting some kind of automated system in place to view a lot of dashboards that we were not having to try to cycle through 40 or 50 dashboards on our monitors up front. Is that another question over here? All right, and this last question. No, we don't have a NOC right now. We are not quite that big yet on the engineering team to have a dedicated NOC. What we do in a lot of cases is the scripts that I was talking about that will query for our aggregate stats or stuff like that, those also act as our pagers. If they see something wrong either on the individual system level or in aggregate across a product, a service, something like that, they will actually page out. And right now, one of the things that we're trying to work on is get away from defining thresholds, which doesn't work so great in an auto-scaling world, and move over to let's do it off of a standard deviation or two, off of historical traffic patterns. And that's, again, the next step that one of the things we want to build out over the next year to make this system more robust. Anyway, I'd really like to thank you all for listening and for the great questions. And again, thank you.